slab, let it be T, and the distance between plates, let it be D. Let this be plus Q, let this be minus Q. Positive plate, negative plate. Okay, now fine. So what is the capacitance of this particular thing? Let me call this terminals X, Y. Now we have to calculate, it's a partially filled, I didn't fill completely. What is the thickness of the slab? T, and area of cross section, let it be A. Then, so I'll rearrange this. Let this be the this is thickness T, this is D minus T, no? And this is slab of dielectric constant K. So what about the field here? The field here will be E naught by K, or say E naught. And what if the field inside the slab? It should be equal to, because dielectric medium, E naught by K. So let me take this is X, Y, this point, let it be Z. Then what is Vx5 from the mathematics? Vx5, we can also write it as Vxz plus Vzy, because Vxz means what you write, Vx minus Vz, Vy. Now, what is the expansion of Vxz? Vxz should be equal to, we know potential difference, field is uniform, so E naught into D minus T. What is Vzy? E naught by K into T, that one. So this should be equal to Vxy E naught T, I'll take common. So minus 1 plus 1 by K plus E naught. Okay, what is E naught? E naught should be equal to Q by A epsilon naught, the field between the plates of capacitor. And what is Vxy? I want to replace this with an equivalent capacitance. So this should be equal to Q by C. Q by A epsilon naught 1 by K minus 1 plus E naught. So this is, so the Q will get cancelled. So the expression will be 1 by C is equal to 1 by A epsilon naught D plus, or this let me write time being, this is, later on I'll adjust it. So what is the expression for capacitance? C equal to F naught A D plus T into 1 by K minus 1, or this equal to F naught A D minus T. So this is the expression for capacitance of partially filled. This is the expression for capacitance of partially filled capacitor. Then, okay, now what are the types of slabs like? So this already we have discussed. Electric field in a dielectric medium E naught by K. Electric field in free space, here it's a free space, will be E naught. So this is a partial field. Let's explore now this particular formula. If I fill up two slabs, then can we modify this formula? So thickness of this will be T1, this is T2, K1, K2. The total distance, let it be T. Can you, it's only applicable for one, or no, it is applicable for n number of slabs of thickness that are placed here. So the formula will be, this will be C equal to epsilon naught A D minus, this will be T1 So this is like this, you can generalize this particular formula. For if there are n number of slabs are there, so even then this formula you can modify it. Okay, got this. So there's a, if n number of slabs are, there's a generalized formula. Okay, let's go for if it is fully filled. If it is fully filled, then what will be the capacitance? This will be the application. Nobody will fill partially. If it is fully filled, then what is the capacitance? So capacitance here, D is equal to T. So capacitance will be epsilon naught A. So T is equal to D 1 minus 1 by K. So this will become K epsilon naught A by D. So when you fully fill up, what happens, the capacitance will increase by K times. So usually the K, what happens for insulators, if you take it, no, some will have 200, some will have 15, 30. So based on that particular value, what will happen? The D, I can make it of order micrometer or millimeter. And the K again will come of order 20, 30, 50, 100. So finally what happens? It gets multiplied by almost 10 to the power of 5 times.